Welcome to the 3D printed filter mask design challenge part 2. You rebel scum. There was a huge response on the last video and a ton of different comments with ideas for improvements and new features. I would like to quickly thank all of you for the feedback. I couldn't possibly implement all of your ideas, but I picked a few and ran with them. Specifically, a more rigid structure and a universal silicone seal. This build requires these items or something similar: 3D printer plastic, silicone caulk, mold release, screws, an elastic band, and some filter material. The printed parts are the filter mask, the silicone mold, a filter cap, and 4 strap locks. Let's take a closer look at the design. The thin plastic and snap locks of version 1 are now replaced by a robust screw-together type enclosure. A simple gasket has been introduced at the edge of the filter cap. This crimps the filter material firmly and reduces the possibility of leakage. The screws also allow for a wide range of filter materials. Thickness up to 1/8 inch is tolerated. The upper edge of the mask has looping structures to facilitate better adhesion of the silicone face seal. Molded to be soft and flexible, the silicone rubber produces a top-quality seal that fits a wide range of faces. Last of all, the 1/4 inch elastic band from version 1 has been upgraded to dual 1/2 inch bands for more support and a tighter seal on this heavy-duty respirator. Once the parts are printed, we can prep the mold for silicone. Sanding the outer edge will keep the silicone surface smooth in a later step. I must be careful not to round over the sides of the mold while doing this. I then roughed up the mold surface and knocked off the top of the layers. For the best quality finish, it's ideal to completely smooth this surface, but that would take a while and I just don't have the time. Using isopropyl alcohol, the parts are thoroughly cleaned and dried. The internet seems to suggest that petroleum jelly is one of the best options for a DIY mold release. In the process of experimenting, I found that a light coat was best. To keep the silicone from sticking to the mold, it was important to work the lubricant into all the various crevices. If too much jelly is present on the surface, it may mix with the silicone caulk and prevent it from curing properly. I used a paper towel to wipe off as much excess as possible. For this demo, I used food-grade 100% silicone caulk. It's inexpensive and widely available. If you have access to silicone mold-making materials, those are definitely preferable. They cure via chemical reaction rather than air drying. For this particular mold, a high-viscosity material would be required. Applying the caulk is relatively straightforward. Starting with the edges, I laid a medium line down into the deepest portion of the mold. Keeping even speed and a slight overlap helps to eliminate bubbles in the application. Using a flexible piece of plastic, like a credit card, the surface is then smoothed out. The ridges on either side of the mold cavity create a user-friendly guide to assist in this process. Any excess silicone is wiped into the mask. I tried using a popsicle stick for this process, but the flex in the plastic card makes it a better tool for the task. Moving on to the mask, the existing silicone was spread over the upper surface. Each loop structure is offset from the last in order to help create a relatively uniform depth for this layer. The lower ridge creates a sort of stop to contain the material. Though using silicone presents some challenges, it is an inert material that is considered to be safe for prolonged contact with the body. It is widely used in medical devices today. After a little cleanup, the two parts are ready to join. The mask will sit on a 1-line thick step at the outer edge of the mold. Be sure not to sand that single line off the part when preparing it. Once these parts are mated with each other, I clean off the excess silicone. 24 hours later, the two can be peeled apart. Theoretically. Be sure to apply enough mold release. Cool and dry temperatures can increase curing times significantly. Getting this process right might take a few tries. With the mask ready to go, it's time for assembly. Step 1. Insert elastic bands. Apply the strap locks, keeping the bands loose for now. Then insert the filter media and screw the two parts together. My filter for this demo is a piece of cotton cloth. It is very important to carefully select your filter media. If you're not sure whether your material is safe for use in a respirator, you should not use it. There is a list in the description that names the most commonly accepted filter material at this time. Next, apply the mask to your face. And adjust the straps. This design works relatively well with a pair of glasses. Someone gave me the idea for replaceable grill pieces, so I tried out a few. With this, you can easily convey emotion in a not at all creepy way. You could even do a little something for Halloween. In conclusion, I feel that this mask is far more functional and robust than the first version. The raw material cost is up from 50 cents to about $2.75. The mask seems to fit most people quite well. One downside is its weight. It's about 3 times heavier than version 1 and therefore not quite as comfortable for long-term wear. Comparing this seal to the one on the 3M respirator, the fit on both is great, but the 3M is a little bit better. They know what they're doing. After all, I recommend using professional personal protection equipment whenever possible. In part 1 of this series, there was a lot of requests for cartridge filters and output valves, but given the time constraints, those were a bit much to tackle. Maybe at a later date I could reverse engineer this whole contraption, but for now, this will be my last video on respirators, at least for a little while. If you all want to see more, let me know in the comments. At this point, I want to divert my attention to building a new desk. Have a look in the description for the part files as well as more details on materials, processes, and any known issues with this design. Thanks for watching. Be sure to like and subscribe for more videos like this.